The objective for this video is to learn how to calculate probabilities associated with a Poisson experiment using the TI graphing calculator. In a previous video, we used the formula for calculating Poisson probabilities to find what the probability would be that there would be exactly 3 flaws in a 100-foot section of coaxial cable that had an average occurrence of 0.067 flaws per foot. The first step was to calculate the mean number of flaws in a 100-foot section, which turned out to be 6.7. In order to find probabilities associated with a Poisson experiment using the TI graphing calculator, we should begin by pressing second VARS. Then cursor down to D for Poisson PDF and press enter. We should begin by inputting the value for lambda. In this case, the value is 6.7. We are to find the probability that there would be exactly 3 flaws. So we'll cursor down to X value and press 3. Press enter and enter again to paste. If you are using a version of the TI graphing calculator that does not present a wizard for inputting these values, it is necessary that the values are input in the correct order. The correct order would be the mean, comma, and then the number of occurrences. Now press enter. We find this probability to be 0.0617. In the previous video, we also calculated the probability that the 100-foot section of this grade of cable would have no more than 2 flaws. This involved summing the probability that there would be 0 flaws, 1 flaw, and 2 flaws. Again, press second VARS and cursor down, this time to E, Poisson CDF. This function will allow us to find probabilities for X values from 0 up to a number. Press enter. Again, enter lambda, which was 6.7. We were to find the probability that there would be 0 or 1 or 2 occurrences. So our X value will be 2. Cursor down to highlight paste and press enter. Again, if you are using a version of the TI graphing calculator that does not present a wizard, you will need to place the values in the correct order, which will first be the mean and then the value of X. Press enter, and we find this probability to be 0.0371. What is the probability that a 100-foot section of this grade of cable would have at least 3 flaws? In the previous video, we used the complement to calculate this probability. We are going to use a complement this time, so we will begin by pressing 1 minus, then second VARS, again cursor down to E for Poisson CDF, and press enter. Lambda, the mean number of occurrences, is again 6.7, and since we will be subtracting the probability that X will be 0 or 1 or 2, our X value will be 2. Highlight paste and press enter. Again, if you are using a version of the TI graphing calculator that does not present a wizard, make sure that you enter the values in the correct order. Press enter, and we find this probability to be 0.9629. We might note that this value is slightly different from the one we found when we did this calculation by hand. The reason for this is because of the rounding that occurs when doing the calculation by hand. The TI graphing calculator performed this calculation all at once and rounds much farther. In this video, we learned how to use the TI graphing calculator to calculate probabilities associated with a Poisson experiment.